In this video, we're going to practice with some examples of how to predict products. The first thing that you need to do in every case is figure out what pattern that you're dealing with. So, for example, looking at number 1, I have an ionic compound with another ionic compound. This would be a double replacement reaction, so I'm expecting the metals to trade places. So looking at this, I've got, the way that I like to think about it is I like to circle the two items that are going to trade places so that I can really clearly see what's happening here. After the reaction, hydrogen is going to now be paired up with the chlorine, and the barium is now going to be paired up with the sulfate, the SO4 polyatomic ion. Now, it is not okay to just write one of each ion, and it is not okay to just carry over the subscripts from the first part of the problem. So notice, I did not take this 2 and automatically put it here. I did not take the 2 on the hydrogen and automatically put it here. I have to figure out, once I have the partners figured out, I know hydrogen's with chlorine, I know barium's with sulfate, then I need to figure out how many hydrogen and chlorine based on their charges. I need to figure out how many barium and how many sulfate based on their charges. So looking at hydrogen, hydrogen is in the first column on the periodic table. It has a positive 1 charge. And chlorine is in the the 7th column on the periodic table, or the 7A column, that has a -1 charge. Just one hydrogen and just one chlorine will give me a total charge of 0 in this ionic compound. Therefore, the formula for the combination of hydrogen and chlorine is just HCl. I'm going to do the same thing with barium. Barium is in the 2A column. It has a +2 charge. If I look up the sulfate polyatomic ion, SO4, it has a -2 charge. So in this case, I only need 1 barium and 1 sulfate to get a total charge of 0. And so BaSO4 is the correct formula. Once you are certain that the formulas are right, that the elements are combined in the right pairs, and that they are combined so the charges add up to 0, then and only then do you balance the chemical equation. So that's the very last step. I have 1 barium on my reactant side, 1 on my product side. I have 2 chlorine here. I need to get 2 chlorine over here, so I'm going to put a coefficient of 2. I have 2 hydrogen here, and that coefficient of 2 gives me 2 hydrogen here. I have 1 sulfate polyatomic ion, and I still have 1 sulfate at the end, so that problem is done. Now we're going to take a look at the second one. Again, first thing I do is figure out the pattern. Here, in the second example, I have a hydrocarbon, something made of carbon and hydrogen, and I have oxygen. That is a sure sign of a combustion reaction. As far as predicting products go, combustion reactions are going to be your easiest because they are very specific. The products of a combustion reaction, once you recognize it, are always CO2 and H2O. You don't have to worry about figuring out formulas or charges or anything. It's just always carbon dioxide and water. To balance a combustion reaction, I usually start with carbon. There are 6 over here. I need 6 over here, so I'm going to do that with a coefficient of 2. Then I usually do hydrogen next. There are 12 hydrogen here. I need 12 over here, which will give me a coefficient of 6 on my water. And I usually do oxygen last. So I've got 2 times 2, or 4 oxygen, plus another 6 from the water. That gives me a total of 10 oxygen atoms on my product side. To get 10 on the reactant side, I'm going to make this coefficient of 5. So combustions are really relatively easy for predicting products. Now looking at the third example, we have an element, in this case zinc, plus a compound. Element plus compound, that is going to be a single replacement reaction. The key in a single replacement is that whatever type of element you have, it's going to replace the same type of element in the compound. If you've got a metal as the element, it will replace the metal part of the compound. If you have a problem where it's in non-metal, it's going to replace the non-metal part. In this example, we have zinc, which is a metal, so it is going to trade places with the metal in the compound, which will be copper. I like to again circle the things that are trading places. It helps me think about it. So after they trade places, copper is the one that will be by itself outside of a compound. Zinc will be a part of the compound. So zinc will be paired up with sulfate. Then I need to figure out the formulas. The element will either just be a single symbol, like in this case where it's just Cu for copper, or it'll get a subscript of 2 if it's diatomic. Copper is not diatomic, so it's just Cu. Then the product will have to figure out the charges. When it's a transition metal like zinc, I would have to tell you what the charge of zinc is or give you a hint. So I'm going to tell you zinc has a charge of positive 2. If you look up the SO4 polyatomic ion like we did earlier, its charge is minus 2. So this actually also turns out to be fairly easy. Minus 2 and plus 2 gives us a total charge of 0, so we just need 1 zinc and 1 sulfate. Finally, we've got our formulas. Last step is to balance, but this is actually already balanced. 1, 1, 1, 1. So we're done with this problem. Moving on to question 4. We've got to recognize the pattern first. We have an element plus another element. That means this is probably going to be a synthesis reaction. Like every problem, we cannot just write the cesium and the bromine on the other side and just leave it. We have to make sure that the charges of that product add up to 0. Another thing I see students do a lot is just carry forward, and they're like, oh, cesium, that's a 1, bromine, that's a subscript of 2, and they just carry them forward and would write a 2 here. That doesn't work. Again, the product formula has to be based on the total charges. So I'm going to look up the charge for cesium and bromine. Again, in this case, cesium has a +1 charge. Bromine has a -1 charge, so we've actually lucked out with some kind of even ones here. Cesium and bromine both have a -1 charge, or both have a positive and -1 charge, so their total charge with 1 cesium and 1 bromine happens to be 0. So CsBr is the formula for cesium bromide. Finally, we're going to balance the chemical equation, and we need to put a 2 here to balance the bromines, and then a 2 here to balance the cesiums, and that one is finished. Last example, number 5. This one also should be easy to pick out. It's just a single reactant. If there is one and only one reactant, the only type of pattern that it can follow is decomposition, so it's going to break down into the 2 elements that it's made of. This compound is made of 2 elements, nitrogen and iodine. And the only real thing you need to worry about here is, since they're elements, are they a single atom or are they diatomic molecules? Nitrogen and iodine actually both happen to be diatomic, so it'll be N2 and I2 instead of just N and I. Finally, we've got the formulas for the product, so we need to balance. To get that, I'm going to put a 2 here. We'll have 2 nitrogen on the product side and the reactant side. To balance iodine, I'm going to give it a coefficient of 3. And we should be done. Now it's your turn to do some practice with predicting products.